Good morning, good afternoon. This is Jonathan from TechSoft 3D. We're very happy to have you join us today to talk about additive manufacturing. And a few people are still filtering in. That's okay. We'll get started. Again, I'm the technical marketing manager here at TechSoft, and I'm joined by James Kerr, the product marketing manager. Hello. And today we'll be talking about additive manufacturing and our different toolkits here at TechSoft and with our partner company, MachineWorks, their Polygonica toolkit, and how we can use that to build very compelling workflows for end-user software in the 3D printing industry. But before we get started, just a few things. All the attendees are on mute, but we do welcome you to ask questions. In fact, we implore you to do so because that really makes for an engaging and enjoyable conversation for everybody. So throughout the webinar, we'll take a few minutes here and there to ask if you have questions, but please don't hesitate to type into the GoToWebinar control panel a question that you may have, and we'll make sure that we answer that either throughout the presentation or also at the end. There's some time for questions and answers. But here we're talking about additive manufacturing and how we can build compelling tools to do so. TechSoft, we really are excited to be working with different types of technology and different types of companies in the 3D engineering industry to help them innovate and to use our tools to build new and exciting applications. Today we'll be talking about that for 3D printing, but really it's great to know the different people who are behind the scenes, the software engineers that are putting together these different pieces to do new and exciting things. And really, as we look at our different customers, we see you guys as partners and partners to success. We're excited to see the cool stuff that you're doing with our technology, and we're proud of it. It's something that we stand behind, including the best-in-class technology if it's for 3D mesh healing or visualization or data access. We really are driven to give you the best set of tools. But also that partnership model is something that we stand behind as well. We're really driven to have an excellent company and culture that is unmatched in the industry. And we invite you to spend time with us at our different offices. Today, James and I we're calling in from the Bend, Oregon office, but there's numerous opportunities for you to engage with us, be it on site by inviting our engineers to come visit you and work with you to create a prototype, or at the different trade shows that we attend throughout the year. So we do invite you to do that. But today we're going to be talking about additive manufacturing. We've done a bunch of research when it comes to that, and Jameson is going to be talking to you about some new exciting things in the industry.
All right, thank you, Jonathan. Let's take a look at market trends in additive manufacturing. The trends clearly show tremendous growth in the additive manufacturing market. 3 years ago in 2014, there were only 49 additive manufacturing system manufacturers. Today, there's over 100, and the revenue tells a similar story. So 3 years ago, there was $4.1 billion for system revenue for additive, and there's been over 25% compound annual growth rate, and so today there's over $6 billion in revenue. Now, taking a look at additive manufacturing software, which is today's topic, revenue is forecasted to be just under $300 million in 2017 and more than doubling in 4 years to over $700 million. And the types of software tools included in these revenue figures are optimization tools, 3D scan software, build prep software, build processing software, production management software, and 3D inspection. So tremendous growth forecasted for the 3D printing market. Sculpteo recently completed their 2017 survey. They're a service bureau based in France and also in California. And it's not surprising that about half of the use cases for additive manufacturing are for prototypes and proofs of concept. What may be a bit surprising is that 22% is used for production. And so we're seeing this trend from prototypes to production for additive manufacturing. In terms of the raw materials used, plastics continue to be very popular, followed by resins and metals. Metals grew from 23% in last year's survey to 28% today. Regarding 3D printing technologies, FDM and SLS are the two most popular printing technologies, and that's followed by SLA and multi-jet polyjet. In talking with our partners in the 3D printing market, we hear a lot about the transition from prototypes to production manufacturing. And in order to make that transition successful, additive manufacturing system providers have focused more and more on creating robust additive manufacturing software. And in doing so, they want to become a more mature technology to serve this growing market that's becoming more and more focused on manufacturing. And users have expressed a lot of interest in more integrated software, software that combines the different tools today into one user experience. And one example of that is Siemens NX recently licensed technology from Materialize to add additive functionality into their popular CAD program. So let's talk about workflows. There's two different groups of workflows for additive manufacturing. The first is production. We see quite a bit of high-value, low-volume manufacturing, such as aerospace applications. And then the fastest-growing market within additive today is application-specific manufacturing. An example of this is dental, which is the fastest-growing application-specific software, as well as medical. So those are some of the fastest-growing segments of additive manufacturing. For prototypes, there are the service bureaus and also in-house rapid prototyping. So let's take a look at the different software tools required to support these workflows. So step number one is importing 3D data. That's typically done from importing CAD data, but it can also come from a scanner that has point cloud data that is converted into a 3D mesh. Once you have that data, there are optimization tools that are used for topology optimization and surface texturing, and in some cases for lattice structure generation. Next are build prep tools used for part orientation, supports, mesh healing, part nesting, etc. After that, there are build processing tools, and this is a necessary part of the 3D printing process, and they slice up the digital file and get it prepared for printing, and they communicate with the printer during that process. For some larger service bureaus, they have production management tools, and these tools coordinate with multiple 3D printers. They make the printing process as efficient as possible for manufacturing purposes or just making a lot of prototypes. And lastly, there are some workflows that utilize 3D scanning inspection tools to verify tolerances.
And James, isn't that true that we're seeing a lot of the mechanical CAD methodologies to manufacturing being applied in this emerging industry now, like 3D inspection? So what we used to do on a CMM machine, we're doing that for parts that are being printed. Also, like in analysis, we see analysis software starting to come into 3D printing. So all those workflows are needing to be built out in up-and-coming software.
And I think that's because the market's maturing, it's moving toward manufacturing, and because of that, it's using technologies developed for other industries. So TechSoft 3D has a group of SDKs that are used for additive manufacturing software tools. So step number one is importing Cad data. And TechSoft, we have Hoops Exchange, which is a market-leading SDK for Cad data access. It's a Cad data translation toolkit that can import over 22 Cad file formats. The second one is Polygonica, and Polygonica can be used with point clouds. When data is taken from a scanner, point clouds are created and they can be turned into a mesh with Polygonica SDK. Next step is optimization, and this is really Polygonica's strong suit. So the Polygonica SDK is excellent at auto-healing meshes, and it can also simplify them to reduce the file size, to slice them, haul them out, and even generate lattice structures. Next is the build prep toolkit, and Polygonica can be used for healing. And also we have engineering graphic visualization toolkits. So the first is Hoops Visualize, that is used for desktop and mobile applications. And the next one is Hoops Communicator, used for web browser applications. And we'll talk more about these later on in this presentation. For build processing tools, Polygonica can slice mesh models from STL and other mesh formats. And for production management tools, Hoops Visualize and Hoops Communicator can display the 3D object that's being prepared for printing. And for 3D scanning tools, Polygonica works well with point clouds for meshing. So the Hoops SDKs, we have Exchange, which is the Cad Data Translation Toolkit. We have Hoops Visualize for desktop mobile applications, Hoops Communicator for web browsers, and also Hoops Publish for exporting 3D PDF, HTML, and standard CAD formats. So those are the four SDKs that are under the Hoops brand, and we're going to talk mostly about Hoops Exchange today, which has the strongest fit for additive manufacturing. So Hoops Exchange can import over 20 CAD formats. It has a powerful tessellation engine and has broad platform support for Windows, Linux, Mac, and also for Android and iOS. It supports neutral formats like STEP, IGES, JT, etc. It's a very high performance SDK for CAD data access. So here's a list of those supported formats, those 20 plus formats. So they include all the popular CAD file formats out today. So Siemens XT, JT, NX, STEP, IGES, SolidWorks, CATIA, Creo, Pro-E, Inventor. We have them all covered here for additive manufacturing.
So what's nice about that is originally as this 3D printing workflow started, the file format of choice was STL. But now we see a real trend when we're going to high value manufacturing, or maybe when it comes to aerospace or automotive. People want access not just to that STL file, but they want access to the original CAD data and be able to work with that. And that's really what the value that Hoops Exchange brings, is it gives you access to the native data without having to have a seat of, let's say, CATIA or SolidWorks or NX. So we are able to give you access to all of this native BREP, bring it into your workflow, and eventually then tessellate it, but it gets you much closer to the actual design of the part.
Yes, and Hoops Exchange is the highest performing SDK on the market for CAD data translation. Its load times are over 8 times faster than the leading competitor, and it has fantastic support for colors, layers, and also broad platform support.
So before we start talking about Polygonica, this might be a good opportunity to entertain any questions about just hoops exchange or that market research. So let's open it up for any questions. I'll give you guys just a minute. All right, well, I'm sure we'll have some in a bit here. Well, James, he talked about getting data into your system, and a fantastic way to do that, especially if you need access to original CAD files, would be using hoops exchange. Now, once you have access to the data, either it comes in as an STL file or as a CAD file, many times you need to prepare that for printing. Particularly those STL files are not well behaved, and here's in terms of the way in which the triangles are defined, and there's errors that are inherent within those meshes, and it needs to be cleaned up. Watertight solid needs to be created, and then maybe even additional modeling to prepare the model for 3D printing has to happen, and that's where Polygonica comes in. Polygonica is a software development toolkit. It comes from MachineWorks, which has a long history in modeling. Particularly, their MachineWorks product is used to model subtractive manufacturing in the CAM industry, but it also has a fantastic number of tools that are quite useful for the 3D printing industry, and those tools are packaged in a complementary SDK called Polygonica. Even though this is a relatively new SDK, the underlying technology from MachineWorks has been proven technology used in industry for over 20 years, but now it's being adapted for 3D printing. And so the real focus of Polygonica is this automatic mesh repair. So with very little or no user intervention, you bring in a mesh and it repairs it and makes it watertight and corrects any errors that might exist there for 3D printing. But then there's also a whole number of other tools that are useful for this 3D printing type workflow, including Boolean operations. So that might be subtracting one part from another, or creating an interior void, hollowing out the part, or taking numerous parts and Booleaning them together, unioning them together and preparing them for 3D printing. As Jane mentioned, simplification is also important, especially if you are using a reverse manufacturing workflow where your data is coming in from a set of scan points. That tends to be very dense data, very heavy in the number of triangles that are created from a scan. And so using Polygonica, you can simplify that and very easily allow it to be transportable. There's some new tools that allow for analysis like feature detection, as well other analysis tools like overhang calculation to see if a support structure needs to be generated, or thin wall detection using Polygonica. Those are other analysis tools that help you determine if your part is printable or. So Polygonica is a modeling toolkit, but particularly it's used for mesh repair, and there's different ways in which it does that. It does it automatically using the API. You can kind of step through these different steps of mesh repair, do them all at once. So an example of that would be your solid closing. Many times data gets brought in and it has holes in it, so the mesh itself isn't watertight, and part of Polygonica is closing those holes. There's a number of different ways that you can do that. Also, the files that you might be using have triangles that aren't facing the same direction, and they all do need to be facing the same direction in order to show where the object is solid and differentiate between the inside and the outside of the solid. So Polygonica will go in and flip triangles and give them all the same unified rotation and orientation. It also looks for triangles that are intersecting with one another or non-manifold. So a non-manifold triangle would be 3 triangles sharing the same edge. Normally you only have 2 triangles sharing the same edge, but if you have 3, that's something that can't be printed and that has to be resolved. As well, many times you have what is called noise solids. These are small sets of triangles that represent a solid that might have come from a scan that was generated from points that possibly weren't filtered out when noise was removed at the scan step. or at the processing meshing step, and so you have these noise solids or the result of a healing operation, they can be easily filtered out as well. Now all of these are very critical because data coming in, especially from existing STL files, can be a pretty poor quality. There's a whole lot of data out there in STL files, and not all of them are ready for 3D printing, and so that's really important workflow and critical for these processes. As well, there's a number of other tools in Polygonica that are applicable for 3D printing. So numerous types of booleans. That allows me to union, subtract, and intersect different objects, as well as offsetting in and out. So it's possible, let's say in this case I have a solid bunny, and I can offset that solid either in or out. Let's say I offset it in a certain amount. Now I have two bunnies, one of the existing size, one of the offset in size, and I can subtract one from the other, thus hollowing out that solid. We have a question. Does Polygonica expose all of these functions as an API? Example, no graphical user interface needed. Yeah, James, good question. So all of the stuff that we're showing you here, they're APIs. And yes, Polygonica can run, let's say, on a server without any sort of UI, and it's just a library. It has its own graphics engine based on OpenGL that you can bind to, or as we're going to show you in some demos, you can visualize data from Polygonica using Hoops Visualize for desktop and mobile native applications, or using Hoops Communicator if you want to build out a web application. But no, you don't have to be able to see those solids at all, and many times it's just sitting on a server doing the processing anyways, without any UI. Okay, good question. Defeaturing, if we were to take a solid and offset it out and offset it back, that's one option to smooth or defeature some of the surface features, as well as we can remove other features from within a solid. And then, as James mentioned, we can very quickly slice a solid and provide you the profile lines that can be sent to the printer for printing out a particular slice in the 3D printing step. There's some new features in the most recent release of Polygonica, which is 2.0. It came out last year. This is around point cloud meshing. So a number of new functions for taking point clouds, possibly from multiple scans, and first registering those scans with one another so that they exist in the same space, smoothing out the point clouds if there's noise in the point cloud. Meshing the point cloud, of course, is critical to this workflow to then print something from a point cloud. You can also bin the point cloud or remove every X number of points to minimize its size. There's also a set of remeshing algorithms that take, say, a mesh with triangles that might be narrow and quite long and remesh them to more unified triangles. From there, you could do modeling operations, Boolean operations, or feed that into an analysis kernel that requires more uniform triangles, and that's part of the remeshing set of tools in Polygonica 2.0. And then also coming up, it's on the roadmap for 2.1 is Lattice Generation, and we're going to show you an alpha of that in our demos, showing how lattices can be generated to fill in interior voids.
Thank you, Jonathan. A key function of any additive manufacturing software is to display the 3D model that's to be printed. And Hoops Communicator enables that in a web browser. And it's scalable modular architecture. It has both server-side and client-side rendering. It has intelligent streaming and on-demand instant viewing. It's a very powerful toolkit for the web and has been popular with some of our partners for service bureau applications that are web-based. We also have a toolkit for native applications, so desktop and mobile applications, and that's Hoops Visualize, which is the gold standard graphics engine for engineering software, and it can be applied to the additive manufacturing market. It's an engineering-focused SDK, and it has very broad platform support. Works on Windows, Linux, Mac, Android, iOS. It's a very powerful SDK for visualization and would be a good fit for any desktop or mobile additive manufacturing software.
We're going to show you some of this in action. While we get that set up, if there's any questions, please feel free to ask them now. All right, thank you, James. So let's take a look at a few different workflows using these toolkits. What we see right now is the Hoops demo viewer, and I'm going to bring in some data here. The Hoops demo viewer is based on Hoops Visualize, as well as Hoops Exchange, and this is linked to Polygonica as well. So this is a Windows-based desktop application. But here I'm going to bring in a Pro-E file, this small mounting bracket for a steering wheel column. And using Hoops Exchange, we read that native Pro-E file without an install of Pro-E on this computer, and brought it in, tessellated it. So within Hoops Exchange, there's a very powerful tessellator. We brought those triangles to Polygonica and asked for Polygonica to tell us if there's errors that exist. And that's the case. So here we see in red triangles that are intersecting with one another, as well as in green, here there's an open edge. So these triangles don't quite meet either. And these are things that need to be healed prior to being able to print this part. And you see those metrics here, as well as the number of points, number of faces. It's not closed, it's not manifold. It has intersections. The triangles are oriented correctly, but we have to fix this. And that's really what Polygonica is great at. So first thing I'm going to do is I'm going to heal this. So again, we ask Polygonica, please take that solid and heal it. It returns to me a collection of triangles which we visualize with Hoops Visualize, and now everything's true. And if I wanted to, I could come and I could export this either as an STL file or as a 3MF file. This is a new file format, relatively, specific for 3D printing, that has some additional features like coloring and instancing that STL doesn't have. So we're able to export both of those file formats for 3D printing. But let's look at a few other tools that are part of Polygonica. So one thing I mentioned was its ability to do booleans and its ability to hollow out, and we're going to do that. So right now we add a cutting plane using Hoops Visualize to this model, and let's now hollow out the model. So I'm going to say offset that surface by 1 unit, and then subtract that offset from the original. And now that creates an interior void in that solid. Well, the problem with that is I wouldn't be able to print that now because I have overhangs inside. And if I wanted to, I could add a lattice structure to this model that allows me to add support within it. And so using Polygonica, we feed it a set of lines. It takes those lines and it clips it from the original interior void, and then returns to us a set of lines that we can then display here as solids. That's really where Polygonica works well, is doing these very fast booleans, either creating this hollowed out structure or taking a existing lattice structure and clipping it to make sure it fits within the space that you want it to. We can talk a bit more about that either offline or at the end. What Polygonica doesn't currently have right now is a set of predefined lattice cells that repeat in space. So I just want to be clear about that. There are some limitations right now, but also that's that's really your intellectual property as well. You know, let's say, your machines and what they're capable of doing, and we'll kind of let you do that, or we'd be happy to also assist you in creating those lattice structures. So we saw this part get brought in as a Pro-E file, and then healed and hollowed out, and a lattice is generated. But let's take a look at a reverse engineering workflow that's very similar. So here we have that same part, but now it's represented as a collection of 50,000, let's say, scan points that we're able to bring in and visualize. And again, using Polygonica, we can take that set of points and mesh them to create a solid. Now here, there still are errors in the way in which the meshing was done, a few open edges and also some intersecting triangles. So again, part of the workflow would be to heal that. So we let Polygonica, again, heal this set of data. But it's quite dense. So it's 110,000 faces, 55,000 points. So also, using Polygonica, we can simplify this mesh, particularly these very flat surfaces that are high density of triangles don't need to be that way. So I'm going to reduce, or attempt to reduce, this mesh size by 90%. So this goes in and decimates flat surfaces and creates a smaller set of triangles. So now, instead of 110,000 faces, we have just 11,000 faces. So much smaller file here to work with. And then lastly, if I want to, I can create a set of slices here, and we're going to do that along the x-axis. And so if I zoom in, you can see that the slices represented. We can now export those as a set of lines that can then be interpreted by your printer and printed. So that's one workflow, using a desktop application to bring in CAD data, either scan data or you saw a Pro-E file and we were able to heal it and prepare it for printing. Let's look at a similar workflow here. This is, again, Polygonica, but this time it's paired with Exchange and Hoops Communicator on a server. And so we're looking at a web page here, and I can take, again, a file. Let's this time take an STL file. I can drag and drop it onto the canvas here in this web page. It takes that file, it sends it to the server. It then opens the file using Hoops Exchange, tessellates it. In this case, it's an STL file. The triangles already exist. Brings it to Polygonica, interrogates it for errors, like here, again, intersecting triangles, or here at the bottom, a very large open hole that needs to be filled before we print. So the first step would be to heal this. Let's say I wanted to emulate the experience of a 3D service that would be online. So I need to heal this. If we look at the model status, it says that it's closed, or it's not closed, it's not manifold, it has intersections. And so again, we're going to send a request up to the server to say, please heal my data. Polygonica heals the solid on the server and then sends down the resulting information here. So now my solid is healed and ready to be printed. If I wanted to, this is a pretty dense file. I could simplify it. So again, send a request up to the server, do something on the server. Now instead of 50,000 faces, I have 20,000 faces. Since this was an STL file, there was no units information. So we might want to decrease the scale of that. We might want to change the material to, let's say, a polyjet, and then also change the color of that to print. Also, if I wanted to, I could hollow that out. So here we also activate a cutting plane and show the hollowed out surface. And if I wanted to, I could review and check out. So just showing you different stages along the way. The same works if I look at that other file. If I come in here and take my Pro-E file, I can do the same thing. If I want to, I can heal it, step through that, and print it as well. So just a few quick demos there showing how you can use Hoops Exchange to read data, Polygonica to heal and prepare the data for 3D printing, and then these different graphics engines, if you want to, you don't need to, these different graphics engines for visualizing either on a desktop application, you could use Hoops Visualize on a mobile application as well, or Hoops Communicator that runs within a web page.
Thank you, Jonathan. So in summary, SDKs from TechSoft 3D can help accelerate your software development for additive manufacturing. We have powerful SDKs for importing CAD files so that you can move your additive application beyond just STL files. So if you want to move into more engineering-specific applications, you can license Hoops Exchange and import over 20 CAD files into your application. For service bureaus that want a web-based application, Hoops Communicator can help you do that. And if you need to heal meshes, Polygonica is the best SDK on the market for automatic mesh repair, point cloud meshing, and other mesh processing. TechSoft 3D, we have a free 60-day evaluation for all of our SDKs, and we have full support from our consulting engineering teams that can help answer questions, help you build prototypes, and so we'd be happy to partner with you, work through a free 60-day evaluation, and answer any questions that you may have. So for this webinar, please feel free to type in questions and we'd be happy to answer those for you now, or email Jonathan or myself at techsoft3d.com. That's James at techsoft3d.com. And also for the free software eval, it's techsoft3d.com/trial. So just type that in and start your trial and we'll get you going. I see we have some questions here.
All right, so does Polygonica provide APIs to manipulate the 2D slices? For example, offsetting and clipping 2D polygons and lines. That is a fantastic question. I think I'd have to get back to you on some of that. So we could offset the surface, and that would give you your offset polygons. And then clipping, I don't think we have extensive clipping within Polygonica, but we do have a number of clipping tools in our other SDKs. So to be pretty specific, I'd be happy to explore that with you a bit more and see if we can meet your needs there. Any other questions? All right, well, like James mentioned, feel free to reach out to either him or myself, and we'd be happy to assist you. Thank you so much for your time today. We really do appreciate that. We hope that you do have the time to sign up for a trial and work with our team to build a prototype. This is going to be recorded, so we'll send out that recording to you once it becomes available. So if you have colleagues that missed this or you want to review some of the material, you're able to do that. But again, thank you so much for your time, and we look forward to working with you in the future.